I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about decimal to binary conversion. In some simple steps, we will see that how any decimal number can be converted into binary number. Let us see one binary number and some of the terminology concerned with the binary number. We have LSB, and that is known as a least significant bit. We have any binary number and we have right extreme position, that is known as LSB, that is least significant bit. And we have MSB, that is most significant bit. On the left hand side, the extreme position bit, that is known as the most significant bit. Let us take one example. Suppose we have one binary number, that is 1011011. Then on the right hand side, so that is known as LSB, that is least significant bit. And on the left hand side, we have at the extreme position, that is known as the most significant bit, and that is MSB. We normally write our values from right to left, that is from least significant bit to most significant bit. So this is something very important when you are converting your decimal number into binary number. Then you will be able to know that what is meaning of LSB and MSB and how to write any binary number. So now let us proceed further for decimal to binary conversion. Step number 1. To convert integer values of decimal number into equivalent binary number, we need to divide decimal number repeatedly by 2 until quotient becomes 0 and remainder will give you equivalent binary values. We'll see one simple example and then this statement will be very much clear for you. Same way, sometime we have mixed number and we have fractional value in decimal numbers. So step number 2, to convert fractional values of decimal number into equivalent binary number, we need to multiply decimal number repeatedly by 2. In this video lecture, we will see conversion of decimal number into binary number for only integer values. For fractional values, we will see in our next video lecture. So step number 2 will be applicable in another video lecture. Currently in this video lecture, we will convert integer values of decimal number into equivalent binary number. So we will use step number 1, that is known as a division, a repeated division, right? And the method we use, that is known as a ladder method. So now let us take one very simple example and then we'll able to see that how decimal number can be converted into a binary equivalent number. Now let us take one very simple example and then we'll able to see how any decimal number can be converted into equivalent binary number. Let us take one decimal number and that is 22. We know that to convert integer value, this is integer value. So to convert integer value of decimal number into equivalent binary number, we need to divide repeatedly by 2. So let us start division. So let us divide by 2. If we divide 22 by 2, then we know that it comes 11. So there is no remainder. So we need to write either a remainder 0 or whatever value is. So it is 0. when we divide 22 by 2, quotient is 11 and a remainder is 0. So again we need to divide quotient by 2. So again 2. If we divide 11 by 2, then it comes 5. But 5 multiplied by 2, that is 10. So we know that there is a remainder 1. We need to write the remainder on the right hand side column. And we need to go on dividing the quotient until it becomes 0. So let us now divide 5 by 2. Then quotient will be 2 and remainder will be 1. 2 2s are 4. So remainder will be 1. Now again we divide by 2. So it comes, quotient will be 1 and remainder will be 0. Now if we divide 1, quotient is 1 and divide by 2, then we know that division may not be possible. So we'll write 0 and the last quotient, that is 1, that automatically becomes a remainder. So now the process has been completed. When we get quotient 0, we need to stop the process. Now the uppermost value of remainder we have written in the right hand column, that is LSB, and lowermost, that is known as MSB. And we know that we always write our binary value from LSB to MSB. So ultimately we will get our binary number equivalent to 22. 22 is our decimal number, and we have calculated our equivalent binary number, and that is 10110. See, position of LSB and MSB, that is very important. You need to know that how to write. Sometime if we write in a reverse position, then we'll be getting a very wrong value. So the position of LSB and MSB is very important. Now let us take one more example, and then the things will be very much clear for you. So let us take 101 and we repeatedly divide by 2. So 101, if we divide, then we get 50. Quotient will be 50. 50 multiplied by 2, that is 100. So we know that remainder will be 1. If we divide 50 by 2 again, then we'll get 25 and remainder will be 0, because 25 multiplied by 2, that is exactly 50. Again if we divide by 2, quotient is 25, so we'll get 12. 12 2s are 24. So we'll be getting a remainder 1. Divide by 2 again, then 6, remainder will be 0. Again quotient is 6. If we divide by 2, then we'll get 3. Remainder will be again 0. Divide by 2, our quotient will be 1 and we will get a remainder 1. Now this last step, that is very important. If we divide 1 by 2, then the division may not be possible. So we have to write 0, quotient 0, and our remainder is 1. So now when we get quotient 0, we have to stop our process, and then let us see the uppermost value of remainder, which is written in the right hand side column, that is known as LSB, and the lowermost is known as MSB. Again we write our binary value from LSB to MSB. So ultimately a value, decimal value 101, and equivalent binary we will be getting 1100101. That is our binary value. See, again I repeat that position of LSB to MSB. If you write from MSB to LSB, or you write LSB to MSB, there is no any it doesn't matter, but you should know that where to write LSB and where to write MSB. Let us take one more example, and then we'll finish our this conversion. Then you can do some practice on your own, and I hope that it will be very easy for you to convert any integer decimal value into equivalent binary value. Let us take one more example. Suppose we have a decimal value, that is 84. Now let us start dividing 84 by 2. If we divide 84 by 2, then we will be getting 42. A quotient will be 42 and a remainder will be 0. We divide 42 by 2, then we get 21 and again a remainder will 0. We divide 21 by 2, then we get a quotient 10. 10 multiplied by 2, that is 20. So there will be a 1 remainder. If we divide 10 by 2, quotient will be 5 and a remainder will be 0. If we divide 5 by 2, then quotient will be 2 and a remainder will be 1. Again, if we divide 2 by 2, then quotient will be 1 and a remainder will be 0. Now this last step is very important. If we divide 1 by 2, then division may not be possible. So quotient we have to write 0 and the last value of quotient 1, that automatically becomes your remainder. So it becomes 1. Now position, we know that LSB, that is uppermost value of a remainder, and MSB, that is the lowermost value. Then we need to write LSB to MSB. So 84 decimal value, that is and equivalent binary value is 1010100. So I must stop here. I hope that this conversion process from decimal to binary, it is very useful to you and you can do some practice on your own, so it will be very much clear. In this video lecture we have studied about only conversion of integer value of decimal number. In next video lecture will be study about fractional value or mixed numbers, and then the things will be very much clear to you. Thank you for watching my video. Keep watching. Thank you very much.